Welcome to NASA's Summer of Innovation lesson videos. I'm Julie Muffler, and this is the Sky is Falling lesson and Searching for Meteorites activity. Almost everyone has gazed up into the night sky to catch a glimpse of a falling star. Your students will learn the difference between meteors, meteorites, meteoroids, and comets as you and they explore the Sky is Falling lesson activities. The Sky is Falling lesson includes 3 activities: searching for meteorites, impact craters, and follow the falling meteorite. In this video, we will take a look at the first activity, searching for meteorites. NASA Eclipse is a great resource for both you and your students to get background information. Let's watch a portion of the eclipse on meteorites.
Today we're going to learn about how NASA's been studying meteorites and comet dust to learn more about our world. Dr. Mike Zielinski is a cosmic mineralogist at NASA's Johnson Space Center in Houston, Texas. He studies rocks from outer space. These space rocks are called meteorites and are basically samples from other worlds. These samples contain the materials, like carbon, that make up our planet and other planets in our solar system. Scientists call these materials the building blocks of the universe.
As the teacher, you may choose to use the video prior to the activities or following the activities. I like to use it first to establish a common knowledge base. After the video, you will be able to survey the students for definitions of these key terms. A common misconception is that students think meteors are comets or falling stars. Be certain that they understand that meteors are dust and debris. Although meteors may come from the debris of a comet, they are not comets themselves or falling stars. The objectives of this activity are: 1. The students create a model of a meteor that will impact Earth. 2. The students will assess various terrains for meteorite recovery. And 3. They will make predictions, graph results, and draw conclusions. Finding meteorites is quite difficult because most meteorites look like Earth rocks to the untrained eye. Meteorites are rarely found in forest or fields where they become lost or buried among the plants. In rocky areas, meteorites are hard to find because they tend to be dull black, gray, or white. In this activity, the students will determine in which areas they are more likely to find meteorites. As you may guess from the image, the models of the meteorites the students make are water balloons. Prepare the students ahead of time to dress appropriately and plan to be outside. Materials include balloons, flour, aquarium gravel of different colors, graph paper, funnel, water, measuring cup, and skewer. Shown here are the procedures that may be found on the student activity page. This activity is done in groups of 3 or 4 students, although each student prepares and throws his or her own model. They work in teams to choose the area, make predictions, record observations, and draw conclusions as instructed on the student page. The first thing the student teams do is designate their target area. In their teams, the students discuss the different surfaces that they would consider at their school. Surfaces commonly found at a school site are concrete pavement, sand pits, grassy areas, gravel, asphalt, and water. Take the students outside so that they may choose their target area. As you are walking outside, point out various terrains and ask the students to make a comparison with the area to forest, fields, deserts, ice, etc. Tell them to consider choosing an area that has multiple terrains so that they'll be able to determine which terrain is best in searching for meteorites. Be sure to get permission to use all areas. You may wish to provide tape or rope to allow your students to mark the areas. They may also use a grid marking similar to the procedures used by archaeologists. Note that the students complete individual data of the balloon filling, followed by team data and the question section. The students will work in teams, but each student has made his or her own meteor model, water balloon. When the teacher is ready, the students fill their balloon 3/4 full of water. Do not shake the balloon. Shaking may cause the flour to cake together. Be sure to tie the balloon securely. This step must be done just before going outside to launch the balloons. The students throw the balloons one at a time in the area their team selected. Students may throw the balloons at an angle, lob them, or throw them straight up so that they may impact vertically. They should be reminded to work as a group. In making their observations, the students use the gravel pieces to represent the meteorites. The flower pattern should follow the water and show a clear scatter pattern from the impact. Record observations at the site and then move to the next site. When the team's launches are complete, individuals return to their impact sites to finish the sketch of their scatter pattern. Use the student questions to guide the group discussion. This time is critical, allowing the students the opportunity to transfer what they observed in a meaningful report. So where on Earth is the most likely place for scientists to find meteorites? Antarctica. Here is a recent scientific expedition in Antarctica to do just that. Thank you for joining us as we explore together in NASA's Summer of Innovation.